we studied the graph. Okay, we had done the graph in the previous class. Uh, we have seen the graphs for all the kinds of motion, I guess. Position time, velocity time, and acceleration time. So position time we have done. Seen this when a body is at rest. So what will be the graph? Okay. Then we have seen the graph for the uniform motion. We have seen the graph for the uniform motion. Okay. Seen the graph for a non-uniform motion. Okay. We had seen the graph. After that, in velocity time graph, we had seen for the rest, uniform motion, non-uniform motion. What is the difference between the uniform motion, velocity time, and the uniform motion in the graph? Okay. Then we had seen acceleration time graph. So for acceleration time graph, I had told you that for rest condition, you don't have any specific graph. You don't have any specific graph. Why? Because this velocity when the body is at rest, so the graph will be on this line along x-axis. Okay. Even when the body is moving with the uniform velocity, still the graph will be here only. Still the graph will be there only. Okay. So you cannot draw the graph for the rest. Okay. On acceleration time graph. Okay. Now uniform curve when velocity is constant. When velocity is constant, acceleration is zero. So you will be having this. Okay. Velocity is zero, constant, and acceleration is there. Okay. So this is the graph. Now, non-uniform motion. This is the first non-uniform motion where velocity is constant. If you see, sorry, acceleration is constant. Velocity is changing, but the acceleration is constant. Okay. So I have taken an example over here, and I had tried to explain you this. Then these are the kinds of non-uniform motion. Okay. There are total 5 graphs over here. Okay. Then we studied few things about that. That what will be the slope? What will be the slope of distance time curve will be giving? So the slope of the distance time curve, okay, the slope of the distance time curve will give me velocity. It will give me velocity. This velocity time curve slope will be giving me acceleration. Okay, and acceleration time curve slope will give me jerk. Okay, it jerk. Now this jerk is not in your syllabus. The jerk is not in your syllabus, so you will only focus on distance, speed, and acceleration. Velocity is displacement and acceleration. Jerk is not there in our syllabus. Okay, so we don't have to worry about that jerk. Okay, so but you should understand the slope of acceleration time graph gives me jerk, and what is the rate of change of acceleration? Okay, rate of change of acceleration. So if I write a total acceleration divided by time take, then this will be called as jerk. But this is not in your syllabus, so we are not going to see. Then we had seen area. Okay, area under the curve. Area under the curve. Okay, so area under the curve. Okay, so here. So area under the curve of velocity time graph. Velocity time graph, for velocity time graph, the area under the curve. The area under the curve will give me displacement. And area under the curve of acceleration time graph will give me velocity. Okay, so these things we have already completed, and with this graph is complete. With this graph is complete. Okay, now we are going to see the speed equations. Okay, equation of motions. Okay, equation of motions. Equation of motion. Okay. Now, first equation. Okay, the first equation. We are going to derive the value for the first equation. So the first equation gives us the value of velocity, final velocity, as the body is accelerating. Okay. So let me tell you that this complete thing, what we are going to analyze, this complete thing, whatever we are going to analyze is only valid when you have a constant acceleration. Okay. When you have a constant acceleration, then only this equations will be valid. Okay. If you don't have a constant acceleration, okay, then this complete equation, whatever we are going to study now, will not be applied. Okay. So acceleration must be uniform. So uniform acceleration should be present there. Okay. So acceleration should be constant. Acceleration should be constant. Acceleration is constant. Acceleration is constant. This means also I can say uniform acceleration. Uniform acceleration. Any example for uniform acceleration? Okay. What is it? Free fall. Okay. Free fall. Okay. Free fall is the example of uniform acceleration. Understood? So if this condition, if this is there, present there, then only you will say that all these equations what we are going to derive will be valid. If acceleration is changing, then this will not be applied. Okay. So if you want to see, if you want to visualize from the graph, okay. So acceleration time curve for a constant acceleration, so AT curve will be like this. Acceleration must be constant. Understood? Acceleration must be constant. Fine. So we are going to see the first equation. Okay, we are going to derive the first speed equation. First equation. So suppose a body is there which is traveling with which is just started, which has just started to move with the velocity v. Okay, so I'm drawing a physical situation over here. Suppose this is time t1, this is time t2. Okay, here and here. Here a car is there. Okay, which is currently moving with velocity u, which is currently moving with velocity u. When you see after some time, the same car, okay, has a velocity of v now, okay. So initial velocity is u, final velocity is v. Initial velocity is u, final velocity is v. Understood? Now, because the speed is changing, so there will be acceleration. Okay. So assuming this to be the initial stage, this is the only initial stage, and this is the final stage. Okay, final. Understood? So now what I have to do? Acceleration. Okay, I will calculate the acceleration now. So acceleration will be calculated how? Change in velocity. So always change is calculated by final minus initial. Change is always calculated final minus initial. Okay, change is always calculated final minus initial. So v minus u. What is the total time taken? Time taken is t2 minus t1. T2 minus t1. So that difference is t sub. So here actually what t is the difference. Okay, the time taken. Understood? Now from here, this is acceleration A. Okay. This is acceleration A. Now, what will be the value of v from here? Will it be u plus at? Yes. So this is my first equation. Of motion. Okay. So the first equation of motion is v is equals to u plus at. Okay. Understood? So if I know the initial velocity, if I know the acceleration, and if I know the constant time, the time taken, okay, to do all the to change the speed from u to v, I can calculate the value of final velocity. Understood? This is the first speed equation. Okay. Second, now we have to calculate the distance. Here. Now, whenever you have a average velocity, whenever you have an average velocity, okay, uniform acceleration, whenever you have a uniform acceleration, so the average velocity between the two intervals, okay, suppose from t1 to t2, from t1 to t2, okay, and acceleration is uniform, so the average velocity between these two intervals, okay, will be given as average velocity, okay, it will be given as v plus u by 2, average velocity between t1 and t2, okay. Now time taken is t, time taken is t, time taken is t, okay. So what is the speed now, what is the distance now, what is the distance value now, what is the distance value now? Yes, distance s. How will you give? Velocity into time. Now, what is the value of velocity you have just now calculated? So, is distance S will become velocity v plus u by 2, okay, into time t, into time t. Fine. So now just take t inside. You just take t inside. Okay. You just take t inside. Or you do one thing, you just expand v. You just expand v. So what we are going to do now, substituting, putting v from equation 1. If I take this value of v and put it here, if I take the value of v, this value of v, if I take and put it over here, okay, if I put it over here, understood? So just see what will I get. S is equals to u plus at plus u, okay, divided by 2 into t. Fine. Now just take t inside now. Just take t inside. So if you take t inside, what you are getting? S is equals to, yes, will you get 2 ut square by 2? Sorry, not t square, it will be 2. 2 ut by 2 plus at square by 2. So from here, what do you get? S is equals to ut plus half at square. Okay, and this is our equation number 2. This is the equation number 2. Understood? So speed, distance. The distance traveled will be given as ut plus half at square, where s is the distance traveled. Okay, u is the initial velocity, t is the time, and a is the acceleration. A is the acceleration. Okay, fine. Now, the third speed equation. Okay, the third equation. So we have already calculated from equation 1. We already know that v is equals to u plus at. U plus at. Okay, this is the first equation we have already calculated. And the second equation is what? Just now, second equation we have found out. This is the second equation. Okay, this is the first equation, and this is the second equation. Now, what we are going to do, we are going to square the first equation. Okay, is squaring the equation 1. Is squaring equation 1. Is squaring equation 1. Okay, so what do you get now? V square is equals to, just square the second term on right hand side. So u square plus at whole square plus 2uat. Will you get this? a plus b whole square. Okay, a plus b whole square. So a square plus b square plus 2ab. This is what you are getting. Now, just take u square on LHS. Just take u square on LHS. So v square minus u square is equals to, you get now at square a whole square. This is whole square. Okay, plus 2uat. Understood? You get 2uat. Now, if I take 2a common, if I take 2a common out of this, if I take 2a common, okay. So if I take 2a common, so what do I get here? What do I get here? Ut. What do I get here? Yes. If I take 2a common, so what do I get here? Will I get a t square by 2? Because it is a square t square, and a 2a I have taken outside. So you just multiply this and this. Just multiply this and this. You should get at square. You should get at square. So just check whether we have done correct or not. Just check. So 2a into at square by 2. So this 2 and this 2 gets cancelled. A square into t square. So whatever we have taken common and written over there, that's absolutely correct. Okay, that's absolutely correct. So we have checked that also. Now, what do you see this? What is this value? Yes, what is this value? Ut plus half at square. What is this value? Is it equation number 2? Is it equation 2? Yes. Ut plus half at square. Is it the equation 2? Yes. So v square minus u square is equals to 2as. Is equals to 2as. So from here I can write. V square is equals to u square plus 2as. This is the equation number 3. This is the equation number 3 now. Okay. So equation 1, 2, and 3. These are the equation of motions. Okay. And these are very important. These are very important. You will be having so many numericals. You will be having so many numericals asked on these 3 equations alone. Okay. If you remember these equations, so directly you can solve so many questions. You can solve so many questions if you remember these 3 equations alone. Understood? So any doubt you have in this now? Do you have any doubt in this? Do you have any doubt in this? We are going to do the numericals then. Okay? We are going to do the numericals then if you don't have any doubt. Okay. So just read the question number 1. Just read the question number 1 and try to answer in the chat. Yes. We'll do the questions of the book. Okay. Just read the question number 1 and then try to answer. The distance traveled by an object. Okay. The distance traveled by an object dash displacement. Option A says can never be greater than displacement. That's the wrong thing. Is always equal to. Okay. It can be equal, but it can be also greater. So I see option C is the best. Option C is the most appropriate and correct answer. Okay. So option C is correct. Fine. Option C is correct. Okay. Question number 2. Pick out the vector quantity from the list. Pick out the vector quantity from the list. Pick out the vector quantity from the list. Yes. Is it option B? Okay. Option B. If velocity of the body is increasing, if the velocity of the body is increasing with respect to time, this is with respect to time, then if the velocity of the body is increasing with respect to time, acceleration is said to be positive. Okay, speed is said to be positive. Velocity and speed I cannot relate. Okay, average velocity is positive. None of these. So the best option is A. The best option is A. The best option is A. Okay. Now, the magnitude of acceleration due to gravity is, the magnitude of acceleration due to gravity is, you should not have any doubt, 9.8 meter per second square. 9.8 meter per second square. Okay, good. Question number 5 now. Question number 5. Question number 5. Yes. If velocity time graph is parallel to time axis, then if velocity time graph is parallel to time axis, then, so let us draw that graph and try to see. This is for the question number 5. Velocity time graph is parallel. Okay, parallel to time axis. This is velocity, this is time axis. So this means velocity is constant. Velocity is constant means what? Acceleration must be 0. Acceleration must be 0. Okay, acceleration must be 0 because velocity is constant. So delta V becomes 0. So this implies acceleration is equal to delta V by T. This is 0 now. Okay, understood? This is for question number 5. Question number 6, you check. When the displacement time curve is a straight line but not parallel to time axis. If it is a straight line but not parallel to the time axis, okay, and it is a distance, so xt curve. So we should draw a curve from here like this. Okay. See, you cannot draw a curve like this because they have given it's not parallel to time axis. You cannot draw a curve like this because time will never be at a point. Okay, the time will move on. Then only you will have a motion. Okay, so time is not a constant axis. Time cannot be constant. Same. Okay. Now just see from here what you will have. So here I can say the slope is constant. The slope is constant. And what does the xt curve slope give me? Velocity. So velocity is constant. This means velocity is uniform. Option B. Option B. Okay. Velocity is not variable. Well, velocity is not variable. It's constant over here. It's constant over here. Okay. Then 7th question. The CGS unit of speed is. The CGS unit of speed is. The CGS unit of speed is centimeter per second. Okay, centimeter per second, not meter per second. They're asking me CGS. CGS, centimeter per second. Okay, centimeter per second. This one. Not able to understand 6th sum. Okay. All those who have not understood the 6th sum, just see here. When the displacement time graph is a straight line. Okay. So a straight line means what? How can I draw the straight line on a displacement time curve? So if this is a displacement time curve now, okay, this is xt curve. So how can I draw the curves now? Just see here. not parallel to a time axis. So I cannot draw a curve like this because they have given not parallel to time axis. So you cannot draw this curve. Okay, you cannot draw this curve. Okay, then can I have this curve? No. Why? Because time cannot have a say a particular value and the motion will be there. Time will always be running. Time will always be running. You cannot stop the time. Okay, time will always be running. So this graph is practically impossible to make. Okay, now the third way of drawing the straight line is this on xt curve. The third way is this. Okay, now if you see here, okay, xt curve you have xt curve and this is the slope. This is the slope, okay, theta or rate of change of delta x. So this is delta x, this is delta t. Now this is a uniform line, uniform slope line. Okay, so here slope is constant. Here slope is constant. If slope is constant, so what is actually the slope? Velocity. Okay, the slope of xt curve gives us velocity. The slope of xt curve gives us velocity. So slope is constant. This means velocity is constant. Velocity is constant. This means velocity is uniform. This means velocity is uniform. Okay, so that's option B. Okay, question number 7, option D, centimeter per second. We have been asked the CGS unit, not MKS or SI system, so that you are answering option A. Option A is wrong. Centimeter per second, not centimeter per second square. Centimeter per second square is the CGS unit of acceleration. Okay, that will be acceleration. Per second square will be acceleration. Okay, then this was 7th question. Just see this 8th question. Centimeter, gram, and second. CGS is centimeter, gram, and second. Centimeter, gram, second. Okay. So just see this 8th question. If the change in velocity for a body, okay, for 3 seconds is 15. Okay. So that means within 3 seconds, the velocity changes by 15. The velocity changes by 15 in 3 seconds. So what is the acceleration now? What is the acceleration now? Yes. So acceleration, how do we give? A is equals to delta V by T. What is delta V now? 15. Because they have given me the change directly, they have given me. So 15 by 3, which is equals to 5 meter per second square. Option A. Okay. Now, area under the acceleration time graph gives, yes, area under the acceleration time graph gives its what? Acceleration time graph will give me what? Velocity. Okay, area under the acceleration time graph will give me velocity. And what will this slope give? What will be the slope giving me? What will slope give here? Area is velocity, then what is slope? What is slope? Slope of acceleration time graph. Jerk. Very good. Slope of acceleration time graph will give me jerk. Okay. Okay, fine. The next question is the change in velocity of motorbike. Okay. The change in velocity of a motorbike is 54 kilometers per hour in 1 minute. Okay. In 1 minute, you have a change in velocity of the motorbike as 15 kilometers per hour in 1 minute. Fine. What will be its acceleration? What will be its acceleration? What will be its acceleration? Okay. So you have to convert this kilometer per hour first in meters per second. Okay. First, you have to convert that in meters per second. So if you convert that in meters per second, what you will get? 54 kilometers per hour. 54 kilometers per hour. You have to convert in meters per second. What is the value now? In meters per second, you tell. In meters per second, what is the value? 54 kilometer per hour in meters per second. What is the value? Yes, I got only two correct answers. 15. Good. 15 meters per second will be the correct answer. Okay. So you have to multiply it by 5 by 18. Okay, 5 by 18. So 18, 54, 3 times, and this becomes 15. 15 meter per second will be the speed. Okay, the change in speed is 15. So this is equivalent to 15 meters per second. Okay, in 1 minute. 1 minute is equals to how much second? 60. Okay, so speed, change in speed is 15. Time taken is 60 seconds. Now you calculate and tell the answer. Okay, so what you will get? 1 by 4. You solve it and you'll get the answer. Okay, you solve it, you will get the answer. So option C is the correct answer. Option C is correct. Okay, so these are the short answers. I guess you can do it. Distinguish between speed and velocity. Distinguish between displacement, distance. What is acceleration due to gravity? Okay, all these things you can do. Okay, the velocity of the car changes from 18 to 72 in this time. Okay, then calculate the change in velocity, acceleration. These all things you can do. Okay, here we have a graph question. So suggest the kind of motion of a body from distance time graph. Okay, so we will see this question. We will see this question. Just see here. We are going to see this question. Okay, suggest the kind of motion of a body from the distance time graph. Okay, so from a distance time graph, I have got a graph shown to me. So I'll try to divide it in regions. I will try to divide it in regions. So this is O, this is point A, and this is, okay. So I have divided it in two regions, O to A, okay, O to A, and then I have divided from A to B. Now, just see the graph from O to A. O to A. O to A, what you will have? Uniform velocity, non-uniform velocity. O to A, uniform velocity, non-uniform velocity. O to A, uniform velocity, non-uniform velocity. Uniform velocity. Uniform velocity. Okay? Uniform velocity. So O to A, we are having uniform velocity. So if I'm having uniform velocity, what is the acceleration now? What is the acceleration here now? What is the acceleration here? 0. What is the acceleration? 0. Okay. Now, A to B. Yes, A to B. So from A to B, is there a distance? Is this body making any displacement, or is this body moving? Is this body moving? Yes or no? Is this body moving? No, this body is not moving. Okay, this body is not moving. So what is the distance now? What is the distance traveled? What is the distance traveled? What is the distance traveled? No distance. Okay, so x value is 0. This means the body is at rest. The body is at rest. If the body is at rest, so what is the velocity now? What is the velocity of the body now? What is the velocity of the body now? 0. If the velocity of the body is 0, what is the acceleration now? What is the acceleration now? 0. Okay. So we have visualized all the kinds of parameters that we can do from this given graph. Okay, distance time graph. O to A, what is happening? Uniform acceleration, uniform velocity, acceleration 0. A to B, x is equals to 0. Okay, because the distance. Okay, delta x, not x, delta x better be right. Okay, delta x, change in distance. Okay, change in position. So delta x is equals to 0. This means the body is at rest. Velocity is 0 and then acceleration will be also 0. So I guess you have understood this point. Yes. Have you understood this point? Okay. So just see this question number 9. See the question number 9. Question number 9. Question number 9. Yes. Question number 9. What is the answer? No. Yes. Yes. True. No. Yes. Okay. Let us see. Does a change in velocity necessarily mean a change in speed of the body? No. No. The answer is no. The answer is no. Why? Just see here. If a body is moving on a circular track, if a body is moving on a circular track, okay. So right now, suppose its velocity is 10. Okay. Here also the velocity is 10. Here also the velocity is 10. Okay. I can do that. You can run along a track with the same speed. You can run along a track with the same speed. But is this direction same or changing? At all the 4 points, is the direction same or changing? Yes. Is it changing or is it same? The direction, you are moving clockwise. You are moving clockwise. So, or anti-clockwise, we will assume. So anti-clockwise means you are moving like this. Just see here, all the directions are different. All the directions are different. So at every point on the circle, at every point on the circular motion, the direction is changing. So if the direction is changing, velocity will be constant or changing. If the direction is changing, velocity will be constant or changing. It will be changing. Speed is constant. Okay, the speed is constant. Speed is constant, but the velocity keeps on changing along a circular path. Okay, so this is the example. Okay, this can be the example for this. This can be the example for this question. Okay, understood? What is instantaneous speed? We have already seen that. Give an example. Okay. So these are the long answers. So derive the speed of equation of motions. We have done that. Okay. I'll try to share this worksheet. Okay. The questions based on this equation of motions. Okay. Derivation we have done. Derivation we have done. And questions will be shared with you. Okay. Then how can you find the following? How can you find the following? How can you find the velocity from the displacement time curve? If direction changes, then velocity changes. Yes, correct. If the direction changes, velocity changes. Okay. How can you find out velocity from a displacement time curve? How can you find out the velocity from a distance time curve? How can you find out the velocity from a displacement time curve? Yes, anyone? Anyone who can tell me how can you find out the display velocity from a displacement time curve? Slope, area, velocity you have to find out. Velocity you have to find out. So from a displacement time curve, okay, from a displacement time curve, you will calculate the slope. Okay, by calculating the slope, you can calculate the velocity. Acceleration from velocity time curve. Acceleration from velocity time curve. Okay, acceleration from velocity time curve. 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 This also slope. This one also slope. You people are not answering. Only few people are answering. Slope from slope of velocity time curve will give me the acceleration. How can you determine the displacement? How can you determine the displacement? How can you determine the displacement from velocity time curve? From a velocity time curve, how will you determine the displacement? Yes. How will you determine the displacement? Area under the curve. Correct. Area under the curve. Velocity from acceleration time graph. This also area. This also area. Understood? So I guess you can do all these questions now. Okay. Try to do these questions. Question number 4, 5, and 6 on your own. Try to attempt question number 4, 5, and 6 on your own. Okay. Then okay, then we have a new chapter after this. Try to do these questions. Okay. And if you anybody is having any doubt, you just ask now. If you have any doubt, you just ask now. Okay. If you have any doubt, okay, you can just ask now. These are the, this is the speed equation that we have derived today. Okay. So is this speed equation, the derivation is clear to everyone? Is this derivation clear to everyone? Or anybody is having any doubt here? So first, so just take the screenshot if you don't have any doubt. That second equation is confusing. Second equation is confusing. Okay. So just see here, second equation once again. Okay, I got it where you are getting it confused. Okay. Just see here, there is one thing. Actually, I don't want to go into the calculation for you people. Okay. That's why I have directly taken taken one result. Okay. I have directly taken a result. Okay. This value. Okay. I have taken direct result of this. Okay. So just try to understand that whenever you know the velocity, okay, whenever you know the velocity of initial and final point, okay, just see here, I'm writing this condition over here because this calculation, this derivation thing you'll only have in class 11th. Okay. Class 11th, you will have this as a question. How to get this u plus v by 2 as the average velocity. That is a case, a particular case. Okay. That's the particular case. So what is that case over here? So if uniform acceleration is there, if acceleration is constant, okay, and if acceleration is constant and final and initial velocities are given, if final and initial velocities are given, then average velocity, okay, what is the condition? This is the first condition, that if acceleration is constant, okay. What is the second condition? What is the second condition? That final and initial velocities are given, then v average you can write as final velocity, you can write it as final velocity plus initial velocity divided by, okay. How this comes, what is the mathematics behind this, okay, how this comes, what is the mathematics behind this, you will study only in class 11th, okay. So by now you just understand that acceleration is constant, the condition I have told you, u and v both the points at this point, okay, at this point and at this point, okay, it is given, okay. It's not VANG, it is V average, VAVG, suffix average. It is V average. Okay. This I have written as VAVG, not NG. Okay. This is not VANG. This is V suffix AVG, average velocity. Okay. Average velocity. Understood? So now you just see this now. Okay. So with this result, I'm directly using this result because I don't want to go into the mathematics for you, because this will be too confusing then, okay? Too much of mathematics is not involved for you. Understood? So average velocity, just understand it will be given as V plus U by 2. V plus U by 2. That's it. Okay? V plus U by 2 will be the average velocity. Okay? Fine. So if the average velocity is V plus U by 2, what is the distance now? Okay? What is the distance? How will you calculate the distance traveled? What is average velocity? What is average velocity? Is it total distance? Is it total distance divided by total time? Yes. So total distance traveled is suppose S. Total distance traveled is S. So S will be given as what? Average velocity into time. And what is the value of average velocity? Average velocity value is V plus U by 2. And time taken is T. This time T is given to you. Time T is given to you. What is T here? What is T over here? It is T2 minus T1 is equals to T. The change in time. The time taken. Okay. The time taken is T. So if I'm writing over here, time taken is T2 minus T1 is equals to T. Okay. Here also I'm writing, if you want, V minus U, T2 minus T1. Okay. So T2 minus T1 is T. Understood? Now, after this equation, after writing this, okay, after writing this, what we have done, we have substituted V value. So putting V from equation 1, putting equation 2, putting V from equation 1, okay. Then S is equals to U plus AT plus U divided by 2 into T. And then you just solve it and you'll get this value. You'll just get this value. Okay. So V average is equals to, when you know the initial and final velocities, and acceleration is constant, okay, and acceleration is constant. So you can write average velocity as V initial, V final divided by 2. Okay. When you know the initial and final velocities and the acceleration is constant, you can use this result. You can use this result. And how is this result coming? This you will study only in class 11th, not here. Okay. The result is useful. The result we have to use, and the how it comes is not there. Okay. Okay. So equation number 3, is there any doubt? Equation number 3, is there any doubt? You have to just square the equation 1 and then take the common 2a outside, and then you can get the value v square is equals to u square plus 2as. Okay. Understood? Fine. So let us do few problems on these speed equations. Okay. Let us do few problems on these speed equations. So suppose from the ground, okay, suppose from the ground, okay, a boy is there who is throwing a ball, with 25 meters per second, who is throwing a ball with 25 meters per second. Okay. Understood? Who is throwing a ball uh, with 25 meters per second. What is the height it will travel? What height it will go? It will go. Yes. What height it will go? Understood the question? A boy is there who is throwing a ball with 25 meters per second velocity. What height this ball goes now? Okay. So you just tell me maximum height. Okay. So maximum height we are considering. So suppose you have thrown a ball. So suppose this is the maximum height over here. What is the velocity here? What is the velocity at the topmost point? Because here you know the velocity. Here you know the velocity 25 meter per second. What is the velocity at topmost point? This is the topmost point. What is the velocity over here? 0. Very good. 0. What is the acceleration involved over here? What is the acceleration involved over here? What is the acceleration involved over here? Yes. Acceleration value is 9.8 meter per second square. 9.8 meters per second square. Okay. So we know the value v is equals to u plus at. Okay. Do you have final velocity? Yes, I do have. Do we have initial velocity? Yes, we have. What is the acceleration value now? Yes. What is the acceleration value now? Acceleration value is this. And we can calculate the value of time now. Then we can calculate the value of time now. Understood? We can calculate the value of time. So just see here, v is 0, u velocity, initial velocity is 25. Now, I'm writing 9.8 into t. Now you tell me, acceleration due to gravity is in upward direction or downward direction? Acceleration due to gravity, is it in upward direction or is it in downward direction? It is in downward direction. Okay. It is in downward direction. Ball is moving in upward direction or downward direction? Ball is moving in upward direction or downward direction? Where is the ball moving? Upward or downward? Upward. So ball is moving in upward direction. Acceleration due to gravity is in downward direction. So I cannot use here plus sign. I have to use here minus sign. Then it will become, I'm taking this as 10 only. Okay. I'm taking this as 10 only. Okay. I'm taking this as 10 only. So it will be 10t is equals to 25. So t will become 2.5 seconds. So after 2.5 seconds, it will reach the highest point. It will reach the highest point. Okay, after this time, it will reach the highest point. Okay, we have to calculate the maximum height now. We have to calculate maximum height now. So S is equals to UT plus half AT square. UT plus half AT square we have to do. Now, what is U value? 25. What is T value? 2.5 minus half. G value is 10 and T square becomes 2.5 whole square. Can you solve this now? Yes. What you will get here? 62.5 minus 5 into this will become 6.25. Correct? This will become 6.25. So you just solve this, and you will get the height. Why you took minus 1 by 2? The same reason acceleration is there, na? Acceleration is there, dear. Acceleration is there, na? Acceleration is in downward direction. The body is moving in upward direction, acceleration is in downward direction. That's why we have taken minus sign. No, it's not always that you will take it like that. It's not always like that you will take it. Okay. Suppose I'm taking a different question now. Okay. This was one question where you have thrown a ball upward. Where you have thrown a ball upward. Now I'm releasing the ball. Okay. So now just see here, I'm releasing the ball. Okay. Now what you are doing? You are standing on this building. A boy is standing on a building and he drops this ball. He is dropping this ball. Okay. So he releases the ball. So the velocity is 0 because he is releasing the ball. He is just releasing the ball. He's just releasing the ball. The velocity is 0 then. Okay. Height of the tower is 100 meters. Height of the tower is 100 meters. Okay. You have to calculate the velocity here. We have to calculate the velocity over here now. Okay. We have to calculate the velocity over here. Understood? So what is the acceleration due to gravity now? 9.8. Okay. I'm taking this as 10. I'm taking this as 10. Okay. 10 meters per second. What is the displacement? Displacement is also downward. Just see here. Just try to compare. Here displacement is downward, acceleration due to gravity is downward. Both are in the same direction. Here both are in the opposite direction. Okay. So here we have to take both as positive because they both are in the same direction. Take both of them as positive. But here velocity, this body is moving upward, acceleration due to gravity is downward. That's why I have taken minus sign over here. That's why I have taken minus sign here as well as minus sign here. Understood? Here what I'll do, I'll take plus sign. I'll not take minus sign. I will not take minus sign over here. Okay. So just see here, final velocity will be is equals to U plus AT. Okay. Next will be S is equals to UT plus half AT square. Okay. And the final will be V square is equals to U square plus 2AS. Okay. So now just see this third equation. I can use this third equation. Okay. I can use this third equation because just see here. Initially, you will be having problem that which equation shall I use? Initially, you'll be having a problem that which equation shall I use? Okay. So just see here. If you use the first equation, so I'm not having final velocity. I'm not having time. So I cannot use this equation because two unknowns are there. In this, I know distance. I know initial velocity. Okay. I know initial velocity, but I don't know time. Okay. Then I can use this relation. Why? Because only time is unknown here. Only time is unknown here, and I can calculate everything. Here, just check. U value I know. A and S, both I know, I can calculate V also. So if I ask you to calculate the time now, if I ask you to calculate time now, so use equation number 2. If I ask you to calculate final velocity, use equation number 3. Can you substitute the values and tell the result? Okay, can you solve it afterwards? So S will be U plus, U into T, UT plus half 10 into T square. Okay, so this value is what? 100. This value is what? 0. Okay, so this becomes 0. This is 100. So 100 into 2 divided by 10 root. This is T value. This is time. Okay, this is time 20. Okay, so 2 root 5. 2 root 5 second is the time now. 2 root 5 is the time now. Okay, velocity, how will you find out? Velocity V square is equals to U square plus 2AS. What is the initial velocity? Initial velocity when you are releasing the ball. Initial velocity when you are releasing the ball, 0. Correct? 2. What is acceleration? 10. What is distance? 100. What is V value now? What is V value now? Will I write it as? 10 root 20. Okay, so 10 into 2, so 20 root 5 meter per second. Correct? Do you understand this now? Do you understand this now? Okay, so initially for these questions initially try to find out write down the data, that what all data you have, and then try to see in which equation you can substitute. Okay, in which equation you can substitute the values and get the result. Okay, so initially try to first solve the questions that are formula based. Okay, then we can solve few problems which are good. Okay, so next class I'll try to solve few more problems on these equations. Okay, don't worry, we'll be solving few more problems, and I'll ask like you'll be shared with the PDF also. Okay, worksheet also. So try to attempt all those questions. Okay, so any doubt now? Okay, so I'll end this session now. Okay, thank you.